First and foremost, let's talk about the tangent identity. So the idea here is that we can express the tangent function in terms of sine and cosine only. Recall when we worked with the unit circle that if we had a terminal point on our unit circle described as the point x comma y, then cosine is equal to the x-coordinate, sine is equal to the y-coordinate, and tan is the ratio of the y over the x-coordinate. So you can see here that we could say that tan of theta, which is equal to y over x, is equal to sine theta over cosine of theta. So this is what I mean by the tangent identity. We can express tan in terms of sine and cosine in this special way. Next, let's talk about the three reciprocal functions, cotan, secant, and cosecant. We've already seen how secant and cosecant can be expressed in terms of sine and cosine. We have that the secant function is the reciprocal of the cosine function, so secant theta is equal to 1 over cosine of theta. Similarly, this is true for the cosecant function. Cosecant can be written in terms of sine, 1 over sine of theta. For the cotan function, we have to do a little bit of extra work. We know that cotan is 1 over tan. We saw on the last slide that we can take tan of theta and replace this with sine theta over cosine theta. And we flip our fraction and multiply to get the final result that cotan can be expressed as cosine of theta divided by sine of theta. So these are our three reciprocal identities that we're going to keep in our back pocket in case we need to use them in the future. In our first example, what we want to do is take this trigonometric expression that we have, rewrite all of our terms using only sine and cosine, and then try to simplify as much as possible. To start, let's work with our numerator, which is cotangent. We saw on the last slide that cotan of theta, we can rewrite this as cosine of theta divided by sine of theta. Also on our last slide, we saw a way to rewrite cosecant of theta. This is the reciprocal function of sine, so we can rewrite this as 1 over sine of theta. And what we have now is we have a division of two fractions. So we're going to set this up to multiply by the reciprocal. So we'll have cosine of theta divided by sine of theta times sine of theta over 1. And you'll notice here that our two sine thetas are going to cancel, and we're going to be left with only cosine of theta. Next, what I want to do is develop three major identities that we're going to use quite a bit in the upcoming chapters. And again, it has its origin in the idea of the unit circle. Let's take a terminal point, P, x comma y. Since we know this point lies on the unit circle, it must satisfy the relationship x squared plus y squared is equal to 1. But we know from one of our slides earlier that we can replace x with cosine of theta, and we can replace y with sine of theta. So what this unit circle relationship is really telling us is that cosine squared plus sine squared of a value theta is equal to 1. So this is our first of three Pythagorean identities. Now, to get our other two Pythagorean identities, we do a slick little trick here. So I'm going to take that expression that I know to be true, sine squared plus cosine squared is equal to 1, and I'm going to divide all of the terms by sine squared theta. And let's take a look at what we have. Here, sine squared theta divided by sine squared theta is equal to 1. Here we have cosine squared theta divided by sine squared theta. We saw this to be the cotangent function, so this is going to be cotan squared of theta. And here we get 1 over sine squared theta. This is the reciprocal function for sine, so we can rewrite this as cosecant squared theta. So this leads us to our second Pythagorean identity. 1 plus cotangent squared is equal to cosecant squared. In a similar fashion, we could take our original expression and we could divide everything by cosine squared theta and see what we get. So first, here we have sine squared theta divided by cosine squared theta. We know that sine over cosine is tan, so this is going to turn into tan squared of theta. Next we have cosine squared over cosine squared, that's equal to 1. And finally, our reciprocal function for cosine is secant, so we can write 1 over cosine squared as secant squared theta. So here's our final Pythagorean identity. In our last example, we want to simplify the following expression. Sine over cos plus cos over 1 plus sine. Now, since we have an addition of two fractions here, our first step is going to be to try to find a common denominator for our two fractions. Our first fraction has the factor of cosine of x in the denominator, and our second fraction has the factor 1 plus sine x in the denominator, so it makes sense to multiply these together to get our common denominator. So I've gone ahead and I've made the common denominator, and I've left our numerators the same. In our first fraction, our denominator is missing 1 plus sine x. So we need to add that in the numerator as well. So you'll see me multiply here by 1 plus sine of x because I need to add that factor into the numerator. In our second fraction, the denominator was missing cosine of x. So you're going to see me here in the numerator multiply by cosine of x to get that missing factor in. Now that we have a common denominator, we can go ahead and expand through and add to get one single fraction. And I'm also going to distribute here through the brackets to get sine of x plus sine squared of x plus cos x times cos x is going to give us cos squared of x. And our common denominator here is cosine of x times 1 plus sine of x. Continuing on from here, we notice that in the numerator we have the expression sine squared plus cosine squared. This expression is always going to be equal to 1, no matter what's on the inside of our sine and cosine functions. We just have to check that these two are the same. So our numerator is actually sine of x plus 1. And maybe you can see now that our numerator is going to cancel off with one of the factors inside of our denominator. So we're left with 1 over cosine of x. And we know what 1 over cosine of x is. That is secant of x. All right, my little epsilons, stay positive.